Right now, Oumuamua is still tumbling end over end, alone in interstellar darkness, and Harvard's brightest minds have no way to stop it, slow it, or explain it. It left our solar system years ago, and it is still accelerating, still speeding up, with nothing pushing it. And what they found buried in the data before it vanished is the part they are afraid to say out loud. In October 2017, astronomers at the Haleakalā Observatory in Hawaii caught something that shouldn't have existed. A blip of light, moving too fast, coming from the wrong direction entirely. They named it Oumuamua, Hawaiian for scout or messenger from afar. The first interstellar object ever confirmed to pass through our solar system, not from here, not from anywhere in this star system, from somewhere else. Another star. It was already leaving when we found it, a narrow, reddish shape, roughly 400 meters long, tumbling end over end like a coin flipped across the galaxy. Astronomers scrambled every available telescope. Hubble, Spitzer, the very large array, they had days, maybe 2 weeks, before it crossed the threshold into deep space and was gone forever. They watched it go. And as it left, it did something that shattered every checklist. It sped up, not by a rounding error. By a measurable, undeniable, calculated deviation from what gravity alone should produce. And in physics, that means something is pushing it. A rocket burns fuel. A comet vents gas, water, ice superheated by the sun, producing a jet of vapor that nudges it forward. We call that outgassing. Astronomers have observed it thousands of times. It is textbook. So they looked for the jet. They looked for the gas signature. They looked for any trace of venting matter that could explain the extra push. And they found nothing. No coma, no tail, no outgassing signature of any kind, just an object accelerating with no visible source of thrust. That should be impossible. But that's not even the part that worries them. Here is where it breaks completely. Every comet we have ever observed, when it outgasses, tumbles harder. The asymmetric jet destabilizes it. Physics demands this. Oumuamua was already tumbling wildly, spinning every 7.3 hours in a wobble so extreme that scientists used the word excited, a technical term for a rotation pattern caused by some violent collision somewhere in the galaxy millions of years ago. If outgassing were driving the acceleration, it would have made that tumble worse. Chaotic, explosive. Instead, the tumble stayed steady, consistent, predictable. The numbers didn't add up. The obvious explanation didn't fit. And for the first time in modern astronomy, scientists were holding data that their best models simply could not reproduce. In 2018, Harvard astrophysicists S.H. Bialy and Avi Loeb ran the numbers and published a paper peer-reviewed, checked, passed through the full process, with a conclusion that sent the scientific world into a quiet, careful panic. They said the acceleration profile was fully consistent with a light sail, a thin, flat structure using radiation pressure, the gentle push of sunlight itself for propulsion. Not a comet, not a rock, not a natural object of any kind we have ever catalogued. A sail. And the paper used the word that every official press release carefully avoids: artificial. Loeb became one of the most controversial scientists on Earth overnight. Other astronomers pushed back hard. They proposed alternatives: a hydrogen iceberg, a nitrogen pancake, a shard of a shredded exoplanet. Every single alternative has a fatal flaw. The hydrogen iceberg would have evaporated long before reaching us. The nitrogen pancake requires a production source we have never once observed at anything near the required scale, and the exoplanet fragment fails on shape alone. Oumuamua was not jagged the way broken rock is. Best measurements gave it a length-to-width ratio of somewhere between 5:1 and 10:1. Long, flat, thin, like nothing our solar system has ever produced, like nothing any solar system we have ever studied has produced. And right now in 2026, the scientific literature is still split. There is no consensus, no agreed explanation. Just a tumbling object somewhere beyond the outer planets, still accelerating, still carrying whatever secret it holds, and pulling away from us at 26 kilometers every second. That number matters. 26 kilometers per second. We are not going to catch it. There is no mission in any space agency's current budget that would reach Oumuamua before it disappears into the dark between stars. We had our window. It lasted 2 weeks. And what we know now is that the first confirmed interstellar visitor in recorded human history behaved exactly like something built. It moved like something designed. It looked like something engineered. And we let it leave. We are building the Vera Rubin Observatory right now. Full sky every 3 nights. It will find more Oumuamuas, dozens, maybe more. And when the next one comes in closer, slower, giving us more time, every telescope on Earth will swing toward it within hours. Every government with a space program will be watching. The data will be better. The instruments will be sharper. And the question nobody in any official statement will answer directly is the same one sitting in that 2018 Harvard paper. What exactly are we hoping it turns out to be?